The good news is that we will be all getting older than our grandparents, but the bad news is that we are going to suffer more from diseases. One of these diseases is Alzheimer's disease. The major hindrance why we haven't yet succeeded healing Alzheimer's disease is the existence of a very specialized cell layer in between the bloodstream and our brain. This cell layer is called the blood-brain barrier. The blood-brain barrier is acting as a human firewall. It is letting essential molecules which are needed inside the brain pass, and others, like therapeutic drugs, are blocked. Apart from molecules, also certain cells can cross this barrier. If you're having Alzheimer's disease, that means you're having an inflammation inside your brain, leading to an increased trafficking of certain types of cells, such as T cells, across this barrier. In my thesis, I'm using these cells as drug transport carrier across the blood-brain barrier. To do so, I'm attaching nanoparticles to the cell membrane. You have to know nanoparticles are particles which are around 1,000 times smaller than the diameter of a human hair. Just imagine these nanoparticles as backpacks. These backpacks I can use to entrap anything I want. But I don't want to put a sandwich inside, like if I would prepare myself to go on a little hiking trip. I want to load them with therapeutic drugs. The nanoparticles are made from polymers, which are long chains of connected molecules degrading over time, leading to a slow release of the drug. I'm attaching these backpacks to the cell surface using different chemistries. This, you can imagine, having different kind of backpack straps. Some are very elastic and comfortable, but you lose them quite quickly. And then there are also others which are tight on your back and tweaking, but they will stay where they are even in the most extreme situations. And that's exactly what I'm interested in my PhD. I'm decorating cells with nanoparticles and observe which one is the best to cross the blood-brain barrier. With this research, I hope that I can make a contribution in improving drug targeting to areas in the body which are difficult to access, with the brain as one example. Thank you.